Okay, today I want to teach you about collecting like terms. Sometimes this concept is also called combining like terms. Collecting, combining are pretty much the same thing. What a term is, if you take a look at this expression, and I can call this an expression because there's no equal sign. If there was an equal sign at the end equal to 6, then this entire thing would be called an equation. But because there's no equal sign, it's really just an expression made up of individual terms. So the individual terms are then separated by the plus or minus signs. Okay, so we have n is a term, 4 is a term, -9 and -5n are a term. These two last ones, if there's a subtraction sign, that term immediately after it takes it and says negative instead of the subtraction. Okay, so this idea of collecting like terms or combining terms is if you have two or more terms that are the same or the similar from the same family, we can combine them into one. So let me show you what I'm talking about. If you take a look at this first term and the last term, they both have a variable of n. Okay, now this one has a -5, and this one really has a 1 as a coefficient. But because of the n is right there, that makes them similar terms. They both are in the family of n, we'll call it. It's kind of silly, but so we would just take these two and ignore the 4 and the -9, and we would just combine those together through addition. So n plus, or 1n I should say, let me go ahead and draw the one there. 1n take away 5n is -4n. Okay, and then the last two are just constants, or just numbers. They're right here in the middle, and this is 4 minus 9 is -5. So all we've done is we have just taken this larger expression and we have condensed it, we've simplified it to this smaller expression, and this problem is over. We're not quite solving yet because this is not an equal sign, we're just collecting like term. Okay, let's take a look at this second problem. This is another expression that contains 4 different terms. 2 of the terms are similar because they have just a y. Actually, all of them have y's, but the difference is in the exponent. So if you notice this -6y squared and 8y squared, they both have that exponent of the 2 above, where the 3y and the 9y don't have it. So because of that very slight difference, even though they both are the same variable, all of them are the same variables, it has to be exactly the same. And so technically they are not like terms just because of the exponent difference. So this first one, we're going to start with the exponent of a 2 in algebra. Everything needs to be in order. So there's this idea of listing your terms in descending order. And what that means is you start with the highest exponent and then you go down from there. So since 2 is our highest exponent, we're going to start there. So this is -6y squared plus 8y squared, which is 2y squared. And then we have 3y. Now we're going to completely skip over this one, and now this one. So 3y plus 9y is 12y. So we're just going to put a positive 12y. So we have our 2 answers. And then when you go back to read it, instead of saying positive 12y, we'll just say plus 12y. So 2y squared plus 12y. Okay, take a look at this last one. This one looks a little different than our first two because hopefully you've noticed these sets of parentheses. Before we can start combining these individual terms in here, we have to do something about the numbers sitting on the outside of the parentheses. And this idea that we're about to do, we're about to multiply through, is called the distributive property. So what we're going to do is we're going to take this 5 and we're going to multiply it twice. Some people find it easier to draw a line to connect the two that you're multiplying. If that helps you, I think you should totally do it. If it confuses you, don't do it at all. So here we go. 5 times negative 2n is negative 10n. 5 times positive 4 is positive 20. And now if we go to our second set, we'll just continue on this line. We have plus 2n and plus 6. Okay, now it's very clear to see our individual terms, and now we're going to collect the like terms. Once again, we have constants, the numbers that are by themselves without a variable, and we have the ones with a variable. Same exponent. Negative 10 plus 2n is negative 8n. And then 20 plus 6 is 26. And that's it. I want you to pause the video because I have a few more problems that I want you to try on your own.